By 1943, shortages forced many rear-area transport wagons, farm carts, and some vehicles to use wooden or steel-banded wheels in place of rubber tires. No pneumatic cushion, just iron grinding against stone roads. This was not a design choice. It was a crisis. Rubber had become one of the most strategic materials of the 20th century. Without it, no modern military could move. Tires, gaskets, hoses, seals. Every vehicle, every aircraft, every piece of mechanized equipment depended on rubber. But Germany had no natural rubber of its own. When war came, that dependence became a fatal vulnerability. What followed was one of the most desperate industrial improvisations of the modern era. At the turn of the 20th century, rubber was a commodity controlled by distant tropical regions. The Amazon basin had long supplied the world's natural rubber, harvested from Hevea brasiliensis trees by indigenous and migrant labor under brutal conditions. But by the 1910s, British and Dutch colonial plantations in Southeast Asia, Malaya, Sumatra, Java, had overtaken South America in production. These plantations operated with ruthless efficiency, feeding the exploding demand of global industrialization. Europe had no rubber trees. The climate would not permit it. For any European nation seeking industrial or military power, this posed a fundamental problem: dependency. Rubber had to be imported. It had to cross oceans. It could be blockaded. Germany recognized this vulnerability early. During World War I, the British Royal Navy had severed German access to global shipping routes. Rubber stocks dwindled, tires wore down, trucks stalled, industry slowed. The memory of that deprivation haunted German strategic planners for the next 2 decades. The concept of synthetic rubber, rubber made from chemicals rather than trees, was not new. As early as the 1860s, chemists had experimented with polymerizing isoprene, the molecular building block of natural rubber. But early attempts produced materials that were brittle, unstable, or prohibitively expensive. Progress came slowly. In 1909, German chemist Fritz Hoffmann succeeded in synthesizing a form of artificial rubber through the polymerization of methylisoprene. It was a laboratory curiosity, not an industrial product. The material lacked the elasticity and durability of natural rubber. It could not be manufactured at scale. World War I accelerated research. Facing rubber shortages, Germany's chemical industry launched urgent efforts to produce a usable synthetic substitute. The result was methyl rubber, used sparingly in cables and seals. It was inferior to natural rubber in nearly every measurable way, but it kept some systems operational. After the war, with natural rubber once again available through trade, interest in synthetics faded. Then came the geopolitical shifts of the 1930s. By the mid-1920s, Germany's chemical industry had consolidated into one of the most powerful industrial cartels in the world, IG Farben. Formed in 1925 through the merger of Bayer, BASF, Hoechst, and several smaller firms, IG Farben controlled dye production, pharmaceuticals, photographic chemicals, and explosives. It was also uniquely positioned to pursue large-scale synthetic materials research. In 1929, IG Farben chemists developed a new synthetic rubber using butadiene and sodium as a catalyst. They called it Buna, a portmanteau of butadiene and natrium, the Latin word for sodium. Buna was more elastic and durable than earlier synthetics, and it could be manufactured from coal and limestone, both abundant in Germany. This was a breakthrough. For the first time, a European power could theoretically produce rubber without relying on overseas plantations. But Buna was expensive. In the 1920s and early 1930s, natural rubber imported from Asia remained far cheaper. There was little commercial incentive to scale up production. That changed with the rise of the National Socialist government in 1933. Under the new regime's autarky policies, economic self-sufficiency designed to prepare Germany for war, synthetic rubber became a strategic priority. IG Farben received state contracts and subsidies to expand Buna production. New plants were constructed at Schkopau, Hulst, and later at Auschwitz, where forced labor from the concentration camp system would be used to build the facilities. By 1936, Germany was producing small quantities of Buna. By 1939, production had increased, but it still represented only a fraction of the nation's rubber needs. The chemical processes were complex. The plants required enormous amounts of coal, electricity, and technical expertise. Yields were inconsistent. Quality varied. Natural rubber still accounted for the majority of Germany's rubber supply in 1939. and nearly all of it came through imports or strategic stockpiling. In the years leading up to World War II, Germany's military planners understood the arithmetic of modern warfare. Motorization was essential. Tanks, trucks, motorcycles, aircraft, artillery tractors all required tires, hundreds of thousands of tires, tires that wore out, punctured, degraded under heat and cold, and needed constant replacement. German industry ramped up tire production. Continental, founded in Hanover in 1871, had become one of Europe's largest tire manufacturers. Metzeler, Phoenix, and Dunlop's German operations also contributed. These firms worked with both natural and synthetic rubber, blending materials to meet military specifications. But synthetic rubber remained a supplement, not a replacement. Buna tires were heavier and less flexible than natural rubber tires. They wore out faster under heavy loads. Soldiers and drivers reported that Buna tires ran hotter and were more prone to blowouts. Engineers adjusted formulations, adding sulfur and carbon black to improve durability, but the gap persisted. By 1938, Germany's stockpiles of natural rubber stood at roughly 100,000 tons, enough for approximately 6 months of wartime consumption, assuming no resupply. When Germany invaded Poland in September 1939, those stockpiles began to drain. The early months of the war did not immediately reveal the rubber crisis. Germany's victories in Poland, Norway, Denmark, the Low Countries, and France came quickly. Supply lines were short. Captured stocks, including French and Belgian rubber reserves, temporarily supplemented German supplies. But the larger strategic picture was darkening. Britain's naval blockade once again severed Germany from global markets. Southeast Asian rubber could not reach German ports. The Molotov-Ribbentrop Pact allowed limited imports via the Soviet Union, including some rubber. But this ended abruptly with Operation Barbarossa in June 1941. Japan's entry into the war in December 1941 and its subsequent conquest of British Malaya, the Dutch East Indies, and other Southeast Asian territories severed Allied access to the same plantations. The United States faced its own rubber crisis, but crucially, the United States had access to Latin American rubber, an intact industrial base, and the capacity to rapidly scale synthetic rubber production using newly developed processes. Germany had none of these advantages. By 1942, Buna production had increased, but it could not keep pace with military demand. Every tank, every truck, every aircraft consumed rubber. The Eastern Front alone devoured tires by the tens of thousands. Winter froze rubber compounds. Summer heat melted them. Rough roads tore them apart. Rubber was rationed. Military vehicles received priority. Civilian transportation, agricultural machinery, and factory logistics were cut off from new rubber supplies. Repair became the norm. Tires were patched, retreaded, and used until they disintegrated. And then, when even that became impossible, they were replaced. The German language had a word for substitute materials, ersatz. It had been used during World War I to describe coffee made from acorns, bread made from sawdust, and fabric made from wood pulp. Now, in the 1940s, it returned. Wooden wheels reappeared, not the solid wooden wheels of medieval carts, but spoked wheels similar to those used on wagons in the 19th century. These were fitted to agricultural vehicles, civilian trucks, and rear echelon supply wagons. The wheels were heavy, rigid, and far less durable than rubber tires, but they could be manufactured locally by carpenters and blacksmiths using available materials. Steel wheels followed. Solid steel rims, or steel bands wrapped around wooden cores, were fitted to trucks and trailers used in industrial transport. Some designs included segmented metal treads, similar to tank tracks but lighter. These wheels could bear heavy loads, but they offered no shock absorption. Drivers reported bone-jarring rides. Cargo was damaged by vibration. Roads, especially paved roads, cracked and broke under the repeated impact of steel on stone. Speed was sacrificed. A truck on rubber tires could travel at 60 kilometers per hour on a decent road. A truck on wooden or steel wheels rarely exceeded 25 kilometers per hour and often moved slower to avoid catastrophic wheel failure. But speed was not the priority. Movement was. Supply columns using ersatz wheels continued to haul ammunition, food, fuel, and equipment to forward positions. Agricultural carts using wooden wheels continued to bring grain to mills and depots. Factory transport using steel wheels continued to move raw materials between plants. The German war economy adapted. It slowed, But it did not stop. By 1944, the rubber situation had become unsustainable. Allied bombing targeted synthetic rubber plants. The Schkopau plant was hit multiple times. Production dropped sharply. Damage to transportation networks further disrupted the distribution of what little synthetic rubber was still being produced. On the front lines, tire shortages immobilized entire units. In some cases, tanks and vehicles were immobilized when rubber-lined wheels and rollers wore through, adding to other growing logistical failures. Trucks were abandoned. Horses and oxen were reintroduced to pull supply wagons, a full-circle return to pre-mechanized logistics. Ersatz wheels appeared increasingly in rear area and civilian transport, where rubber allocations had been cut entirely. Photographs from 1944 and 1945 showed German trucks with mismatched wheels. One rubber tire, one wooden wheel, sometimes steel bands wrapped around improvised hubs. This was not standardization. It was improvisation under scarcity. The final collapse of German logistics in 1945 cannot be attributed to rubber alone. Fuel shortages, personnel losses, air superiority by the Allies, and the destruction of transportation infrastructure all played roles. But the inability to maintain mechanized mobility, a mobility that depended fundamentally on rubber, was a critical factor. When the war ended, the synthetic rubber research and production capacity that Germany had developed did not vanish. Allied forces captured intact Buna plants. IG Farben was dissolved and its assets redistributed, but the technical knowledge remained. In the decades after the war, synthetic rubber became a global industry. The processes pioneered by German chemists, refined under wartime pressure, were studied and improved. The United States, which had developed its own synthetic rubber program during the war using styrene butadiene formulas, continued large-scale production. By the 1960s, synthetic rubber accounted for more than half of global rubber consumption. Europe rebuilt its chemical industry with synthetic rubber as a cornerstone. Bayer, reconstituted as an independent company after the breakup of IG Farben, became one of the world's largest producers of synthetic rubber. Facilities in Germany, France, and the Netherlands supplied the post-war automotive boom. The lesson had been absorbed. Dependence on a single source of a critical material was a strategic liability. Diversification through synthetic alternatives, strategic reserves, and distributed production became standard practice. The wooden and steel wheels disappeared. They were relics of an emergency, discarded as soon as industrial normalcy returned. But their existence had revealed a fundamental truth about modern warfare and industrial society. Without rubber, mobility collapses, and without mobility, everything else follows. The rubber crisis of World War II Germany was not an isolated event. It was the culmination of decades of geopolitical vulnerability, industrial ambition, and the limitations of technology under pressure. The development of synthetic rubber represented one of the 20th century's most important material innovations, driven by necessity and shaped by conflict. The ersatz wheels, wooden, steel, improvised, were symbols of an industrial system stretched beyond its limits. They kept the machinery of war and economy moving, but only barely. They demonstrated both the adaptability of human engineering and the consequences of strategic miscalculation. In the end, rubber shortages did not lose the war for Germany, but they revealed how fragile the architecture of modern industrial power truly was. A single missing material could unravel entire logistics networks, strand armies, and cripple economies. That fragility remains today. The materials that underpin modern life, semiconductors, rare earth elements, lithium, cobalt, are subject to the same geopolitical forces that once controlled rubber. The lessons of Germany's rubber crisis are not confined to history. They echo in every supply chain, every strategic stockpile, every nation's calculation of what it can and cannot do without. Watch next to see how a wartime nickel shortage pushed American engineers to invent new aircraft alloys and keep production moving.